I will explain you what is called a compact. Before that, you have to know what is called open covering of X. That is, I am going to say X is compact, okay? X is a topological space. So now I will explain you the definition of this compact. Okay, to understand about this compact definition, or to understand what they are trying to convey from the definition of compact, you have to know what is open covering. Is that clear? Okay, I will tell you what is open covering. So first you have to consider a topological space X. Imagine this is the topological space X. Within this topological space, usually we will have so many subsets. Is that clear? So here imagine you are having so many subsets within this topological space. From this subsets, I am taking some of the subsets. Few subsets. Okay? Or I can say I am taking a collection of subsets. So if I take these subsets from this topological space X and I am giving name to this script A. Okay, this collection is denoted as script A. That is, I am giving name to every subsets present inside this script A. Okay, so this is A1, this is A2, this is A3, this is script A, this is normal A. Okay. Okay, I named them. Now, so these subsets are present inside this script A. So I am writing like this. Script A is equal to A1, A2, A3 and A4. Okay. Now what I am going to do is I am going to say this script A is an open covering of this topological space X. So when I will say that there is a condition, the script A should satisfy. The condition is that inside this script A you are having these elements, right? So I am going to find the union of these elements. That is, A1 is a set, that is A1 is a subset, A2 is a subset, A3 is a subset, A4 is a subset. So you know how to find the union of given sets, right? In small classes we have learned. Likewise, if we find the union of these subsets, okay, what we will get is this value should be equal to our topological space X. So if this condition is satisfied, then you can say this script A is an open covering of our topological space capital X. Is that clear? I hope you did not got any confusions in what I have said here. Now I will explain you compact. Okay, when you will say this X is compact. Is that clear? So here I told you inside this topological space X you will have so many subsets. Like that, in a topological space X, you will have so many open coverings also. Here we have learned about one open covering. Like that, inside topological space, you will have so many open coverings. Is that clear? Now imagine this is the topological space. I told you that inside topological space, you will have so many what? Open coverings, right? Similarly, this is the topological space X. Inside this topological space X, you are having so many what? Open coverings. Okay. Open covering means you know what is called open coverings. If you are saying script A or B, whatever is a open covering, it means what? Inside that script A, you will have some of the subsets that you will find the union of that subsets. When you find the union of all the subsets present in that script A, that should be equal to X. Then you will say that script A is an open covering. So when I talk about in this topological space X, you are having so many open coverings. These are open coverings now, okay? When I am saying these are open coverings, what does it mean? These open coverings are satisfying the condition of open covering. Okay, inside this script A you will have so many, some of the subsets, finite collection you will have. Okay, finite number of subsets you will have. You have to choose finite subsets within this open covering. So here in the script A1, I am saying the script A1. Okay, what I am going to say is applicable for all these. Okay, if I take A2 means I am saying this A2 is open covering. It means what? Inside this thing should come into your mind. What should come into your mind when I say A2 is open covering of capital X? I will tell you what should come into your mind. When I say A2 is an open covering, your mind should know, that is you have to know, inside this A2 you are having some of the subsets, finite number of subsets, and when you find the union of that subsets, you have to get you will get a value, right? That value should be equal to this capital X. Then you can say that this is a open covering. So if I say these are open covering means all these are satisfying that condition. Okay, now let us come to our definition. I am going to say this X is compact. It means every open covering present inside this topological space X should satisfy the condition of open covering. Okay, every open covering should satisfy the condition. Okay, that is what you will see in a definition. I will show you the definition. The space X is said to be compact if every open covering script A of capital X, that is inside X, that is topological space, you will have so many open coverings. That is every open coverings contains a finite subcollection. We know that in open coverings there is a finite number of elements. There is finite number of subsets, right? So that is what they are saying, contains a finite subcollection. That finite subcollection should also cover X. That is every open covering should satisfy that condition. Okay, what condition? When you find the union of elements present inside this A4, that should be equal to this topological space X. If every open covering satisfy this condition, then you can say this X is compact.